Hi guys. So I wanted to make a video about probability trees. Um, and we're gonna go on to solving something like this, but first I want to talk about probability trees in general because we haven't really had a lesson on it outside of Education Perfect. So probability trees has a few rules and they're quite simple. One, the probability trees are events that go in order. So they happen one after the other, or it's just two events. Okay. Um, so if we have something like a coin flip, let's say I'm gonna flip a coin two times, one after the other. So this is my first coin flip. This is my second coin flip. Um, the way you draw probabilities trees is you draw branches out depending on how many events you have going on. So in the first coin flip, I have two events that might happen. I might either get a heads or I might get a tail. So these branches represent what I might be getting in a scenario. Um, the second event tells us, well, what's going to happen after the first scenario. Let's say, for example, I get heads in the first coin flip. My second options, once I get head, is that I get heads and tails again. Okay, those are our only options. And the same thing, if let's say I get tails the first time, the second time I might either get heads or tails. The options don't change. So the point of a probability tree is to help us organize what's going on, help us see all the options that we have um, in events that might happen one after the other. Um, all right, so that's the first thing. The what is going to happen or the event is going to be written at the end of a branch. So these are called branches. Okay, we place probabilities on top of those branches. So right over here somewhere in the middle. You might have seen that probability trees might have had percentages and not decimals. I would say for me, 100% of the time, I use decimals. I don't, or fractions. I don't use percentages in a probability tree, and I urge you not to. Um, but we know probabilities can be given in percentages or decimals or fractions. So in this case, I have a 50-50 chance of getting either heads or tails, so 0.5 chance, 0.5 chance. Each section or branch has to add up to 1. So if I'm given the probability of 1, I can figure out the other because I can just do the leftover or 1 minus whatever that is. So that's the first rule. They all have to add up to 1. So this one adds up to 1, this right here adds up to 1, and this right here adds up to 1. The other rule about probability trees is when you go across, you are multiplying because we're finding and probabilities. And probabilities, the probability of, let's say, getting heads the first throw, and the probability of getting heads in the second throw is this probability multiplied by this probability. And we know that flipping a coin doesn't change. It's always 0.5, 0.5. But the probability of getting heads the first time and the probability of getting heads the second time is actually, and we write probabilities here. So this is the probability. So right at the end, you might have seen some probabilities. And what this means is the probability of getting heads and heads. So both events are heads. So it's 0.5 times 0.5, which is 0.25. And then we know that the rest is all 0.25 because we have probabilities of 0.5, 0.5. So that's the second rule. So the first rule of probability trees is that all branches add up to 1, 2, we multiply across trees, and 3 is that all the AND probabilities, so probability of heads then tails, probability of tails then heads, probability of tails and tails, all these probabilities also add up to 1. Okay? So AND probabilities add to 1. And those are the basic rules of drawing probability trees. Think of it like a puzzle. So if we're missing a few things, well, we know this adds up to 1, so I can fill this one out. If we're missing these AND probabilities, we know we have to multiply across. If we're missing one of these probabilities, we know that they all have to add up to 1. And if you want to check that your probability tree is correct, you check the AND probabilities, and that should all equal to 1. So that's basics of probability trees. But let's look at something like this one. Stephen is practicing his free throws on a basketball court. Stephen knows his probability of getting 2 shots in a row is 0.6642. The probability of getting the first shot is 0.81. If he misses the first shot, his probability of making the second is 0.57. So what's happening here is that the probabilities are actually changing as the first event moves on to the second event. The first shot that he makes, there's a 0.81 probability of him making the shot, but once he moves on to, if he misses the shot, so we go down here, and I'm sorry it's cut out a little bit, so I'll just write it down. Misses. And this is misses as well. If he misses a shot, his then second shot is 0.57. We also know that the probability of getting 2 shots is 0.6. So we have quite a bit of information that we can, using the rules I just told you about, figure it out. The first one is the most obvious one, is that this has to equal to 1. So 0.81, so what we do is 1 minus 0.81, which gives us 0.19, okay, because they both have to add up to equal to 1. So then we can easily find out the end shot here. So what's the probability of him missing the first shot but making the second shot? It's just 0.19 times 0.57, because like I said, you multiply across branches the probability of him missing a shot and making the shot. So 0.19 times 0.57 is 0.1083. Now, we can find this one, the probability of him missing a shot after he misses the first shot. So what's the probability of him missing the second shot? So that, again, is just 1 minus 0.57. 1 minus 0.57, 0.43. So we figured that out now. Okay. The more tricky part, I guess, is finding out this one. But we can find it out, and we have enough information, and that's just using a bit of math or a bit of algebra, if you'd like. So what you can do is, what you're doing is you're working backwards. We know the probability of making the first shot and making the second shot is 0.6642. So we know that 0.81 times whatever this is equals 0.6642. So let's just say I make it x. Actually, x is, let's say I make it z. Okay, So 0.81 times the probability of him making the second shot is equal to 0.6642. If I write it down in algebra, I have 0.81 times z equals 0.6642. So I want to find out what z is. So what I do is I just divide 0.81 by both sides. Z equals 0.6642 divided by 0.81, which is 0.82. And you can figure out if this is correct by doing 0.81 times 0.82 is equal to 0.6642. Alright, so now we know that this is 0.82, and we can figure out the other one, which is 0.18, because it has to equal to 1. And then you can multiply out each one to figure out the probabilities, the end probability. So let's do that. 0.81 times 0.18 is 0.1458. And then we've already done that one, so 0.19 times 0.43 is 0.0817. We can check if this is all correct by adding it all up. 0.6642 plus 0.1458 plus 0.1083 plus 0.0817 should all equal to exactly 1. Alright, so we filled out the probability tree.